Hello my friends and welcome again to my video channel. Today we will continue our work on this FT221 and I can tell you this transceiver is getting more and more a rabbit hole. There is a new page in the PLL topic I found in the last hours. I will show you the result, what I found. The VCO in the PLL has several components which influence the frequency. We have the PLL circuit itself, which controls this cap diode or varicap, which locks the PLL. Here in parallel we have a second varicap, and this diode is controlled by the so-called tuning voltage, which is controlled via this input, which comes from the band switch. Each 500 kHz segment generates a different voltage for this diode. It is intended that the VCO is shifted up in the frequency so that the PLL range is reduced, but this makes a problem. The next one is this trim cap, and of course we have an inductivity, a coil. In the manual it is stated that at a very low frequency, less than 144 MHz, this trim cap should be set that the tuning voltage is approximately 4.5 volt. I couldn't reach this point, I was above 5 volt, maybe you remember. And this causes a problem because the whole PLL voltage range is shifted up in this way, because I cannot bring it back down or bring it down to this voltage range. Maybe there's an influence of this diode. I have to align the tuning voltage in the next step. But what I did in the first step, I changed the inductivity a little bit. I took out the core a quarter of a turn. This means I reduced the inductivity, and the PLL has therefore to increase this capacity to get lock. Increasing capacity means reducing the voltage. And now you can see on the voltmeter I have the required voltage of 4.5 volt at the lowest possible setting, 144. And the VFO is on the counterclockwise position, most counterclockwise position. Now we have 4.5 and I was able to align this trim cap for this setting. And now I have a stable PLL lock on all bands, at 0, at 500 kHz on all bands. And I think this is a problem. This was the main problem, because we have seen that the board which was installed here was not the original board for this transceiver. We had to modify the control circuit for the unlock indication, you remember, from open collector to emitter follower, like this one. And we had to add the voltage for on pin 6, the missing voltage. So this board was not the right one, this PLL board was not the right one for this transceiver. And I assume that in the factory there is done an alignment for the PLL unit, that the PLL unit, especially this coil here, is set correctly. There is no indication in the manual how to set this coil. Up to now I didn't find it, maybe I will find it later, but I can't imagine. So I think this is made in the factory, so that this coil is in line with the whole transceiver and the setting range of this tuning voltage and for the correct PLL operation. And this was a problem the guy or guys had before, so they made this crazy modification with the RF gain to control the PLL circuit. I will continue now with the alignment according to the manual, and then we go to the next step. The next step in the PLL circuit adjustment requires setting of this 4.5 volt, what I have done. In the left position, the marker is on, and on 100 kilohertz we have a lock. And now I check all bands. This is a 0 indication, 144, 44.5, and each 500 kilohertz segment. The crystals have to be adjusted, but it is okay. And one important check is always when you switch off the transceiver, wait some seconds and then it should come back. This means we are in the locking range. Now we go up 500 kilohertz. Switch off. Switch on. I should do it on the other end also. Well, that's okay. And now we can say that the PLL is done. Next check is the repeater position. They are talking about 146.5. Here in Europe we have 145.5. And when I go to reverse, this is 600 kilohertz jump, but it is okay. Carrier balance setting. The S meter should be placed RF gain fully counterclockwise. That makes no sense. I brought it to the center position, no signal input, and the task is to get this deflection of the S meter in the same position for AM, FM and SSB modes with the trimmer on the SSB IF unit. I'll show you, for example, the trim resistor. There's a resistor and a capacitor. When it is not balanced, we have a difference. AM, FM has less deflection. So we have to optimize it. CW, USB, LSB. There's also a capacitor on it, but there was no big realignment necessary. It is okay. So we can leave it. And now the frequency setting of the BFOs, USB and LSB, should be done acoustically with the same pitch. There is a little bit of difference, but I don't like this method because I don't know which is the right one and the wrong one. So I use a frequency counter connected to the output of the phones, and then use the marker in the mode LSB. I see in mode LSB, when the signal comes up, the frequency is roughly 300 Hertz. And when the signal disappears, we are in the range of 2.4 kilohertz. In the mode USB, the signal is at 300 Hertz. And 2.4, 2.5, there is no big difference. So I think I can leave it at this beginning at 300 Hertz. 250, 300, that is okay. And we have a small difference in the pitch because the SSB filter is not perfect. It's not a square filter, it's an old analog filter, and these analog filters are not parallel in the top. They are in this way, maybe they have peaks, ripple in it, and so there's always an acoustical pitch, but a difference, but this is not a problem. I do not touch it, it's okay. Now to the marker calibration. There are different methods using WWV standard or so, or measure the oscillator, the crystal oscillator directly. I do it with a different way. I have a signal 145.500 exactly. This is heard here, and when I switch on the marker, off, on, and then I bring both tones to 0 beat. Yes, that's it. The trim cap is a little bit sensitive, I found. And now aligning the local unit. These are the crystals for the bands. The counter is connected to the test point. We have here the frequency 41.7666. It's 444.0 according to the instruction. This can be adjusted here with a trimmer. And the proposal is now to use a calibrator or marker. And when we switch to the next band, the oscillator has to be set to the same pitch. And so on. Now a small hint, an old man asked me, he has a problem with his bands here in one setting, I think, of the band selector. What can be the problem? There is no oscillation. Well, of course the switch can be the problem, the switching diode on the board here, contact problem, but most probably we have a problem with the trim capacitors. These trim caps are getting worse with the time. They corrode, get less contact, series resistor appears which detunes the circuit or even stops the oscillation. So try simply to move the capacitor, trim cap. Maybe the problem is solved. Of course the crystal could also be bad, but I don't think so. I've never seen a bad crystal in such a transceiver. It was always a contact problem. 2, 3, 4. They're all a little bit off, but maybe And now there's one crystal installed for the repeater offset. It's the European version, should be active here. And when I go to reverse, I think this is this trim cap. You hear the sound. There are some scratches. So the local unit is also calibrated now. There's only one shift on 140 5.500 for 600 kilohertz. Why these bands here are equipped, I don't know, but okay. We know that this transceiver has an interesting history behind. Now a short VFO linearity check. There's an alignment procedure, but as I've seen, it's linear. We have the 500 kilohertz position. We have 8.500 megahertz. When we go down 100 kilohertz down, we have 400. Here we have 300. This is a 200 position and 100 is also okay, and 0, 0, 0, that's also okay. Calibration should be within 500 Hertz. We are within 500 Hertz, so no further action required. Receiver RF amplifier on 144.200. A weak signal is received from the signal generator. I've chosen a very weak signal, 1 microvolt. And then on the RX RF unit, 4 trim caps have to be set for maximum S-meter deflection. Is there a problem with the tuning voltage? No, this one was maximum. It's also maximum. Is there a 4th trim cap? Deep hole? Oh, okay. They were all optimized. Only the first one was not perfect. Well, and after this procedure, the first resistor or trim pot has to be set for maximum. We have here a row of tuning trim pots for each band. For each band, the voltage for the tuning diodes is set separately to optimize the input, and the VR701 has to be set for maximum. And then go to the next band, increase the frequency, 144.7. Okay. It is maximum, and so on for all 8 bands. We have to choose a frequency 200 kilohertz above this setting, 145.200. And again for maximum. And so on, not necessary to show it for all bands, but as I've seen, the pots are optimal, have the best setting, so no additional alignment is necessary. And this is 147.700. It's also okay, so these pots were okay. No further alignment was necessary, but it was a good check. And it has again an influence on the PLL unit, as we have seen, but I don't fear that there is now a problem because these voltages are okay. And we can do a short check on the PLL unit now, where the tuning voltage, which range is there for the tuning voltage. In the lowest band, fully counterclockwise, we should have 4.5 volt. We can align it down. Yes. 4.8. I leave it there. Let's go to the other bands, switch it up. Not so happy. Should go to 4.5. Touchy, I leave it there. Next band. Okay. Now we go to the maximum frequency on each band. Yes, I think it's okay. I'm gonna switch on the marker. It's on 500. Let's go down to 0. Yes, that's okay now. Squash setting. Mode FM, no input signal. Squash should trigger at 9 o'clock position. Okay. Right setting. Discriminator indication. The mode is FM again. Marker is received. We should tune it for maximum. And then the discriminator should be centered. And well, we should check 10 kilohertz higher. VFO should indicate 8. And when we go down 10 kilohertz, 585, it should go down to 2, nearly 2 with 10 kilohertz. Okay. We don't have a perfect symmetry, but I think it's a little bit more than 8. Center is 5. We have here 0. Yes, discriminator is centered. Now we are at the end of the receiver alignment and also at the end of part 5. In the next part we will do the transmitter alignment and compare this alignment procedure, the so-called factory alignment procedure, with the alignment procedure in the user manual. There are, as I have seen, some small differences in the philosophy. We will check it. We will do also some measurements regarding sensitivity, output power and so on. So stay tuned, stay healthy. See you on this channel.